Whenever you hear a term pressure vessel, you will imagine the vessel will be cylindrical, top and bottom reached with legs. Is it that true? Is it that pressure vessel? Is there only type of pressure vessels we have? No, there are different types of pressure vessels. There are more than 10 to 15 types of pressure vessels, which can be differ from the shape, it can be differ from the orientation, which can be differ from the process which is having, and also it can be differ from the location which is having. In this video we are going to discuss about what are the different types of pressure vessels, in which industries, in which different places we are going to use the different kind of pressure vessels. Those are the topic we are going to discuss today. We will discuss about what are the classifications of the pressure vessel, what are the design, what are the industry application of the pressure vessel. Why so many types of pressure vessels we have unique requirement. Not every process demand a specific pressure vessel, right? If we have a constrained area and we have designed a vertical pressure vessel, means we can't able to insert that vertical pressure vessel inside a constrained area, right? We have to design a horizontal pressure vessel, or we have to design according to the constrained area. So it is based on location, it is based on operation condition, also it is based on pressure, temperature and fluid state detected to the geometry and engineering balance. We must optimize the safety, manufacturing cost and efficiency. Actually this one is very important one, the manufacturing cost, because there are many competitors. If you are working for a manufacturing organization and you are the responsible person for estimation or in proposal, you have to be very much careful in manufacturing cost. If you are quoting a pressure vessel, a high pressure vessel, very high pressure vessel with flat end or with ellipsoidal end, the head thickness gonna be huge. What a good and experienced static equipment engineer will do is he will choose the head with hemispherical head, so that he can able to reduce the material weight, and also he needs to know is it feasible to form a hemispherical head in that particular location. So each and everything has to become with the experience and also with the knowledge. As per the image you can able to see, it is a vertical pressure vessel with skirt, it is a horizontal pressure vessel with saddle support, and this is a spherical pressure vessel. So there are different types of pressure vessels we are going to use in different places. The pressure vessel classification, the classification of pressure vessel can be by shape, by orientation, by function, by pressure, by head type, by support. By shape means previously you can able to see it will be cylindrical, spherical or any other shapes. Even rectangle also we are building the pressure vessels. By pressure, if it is high pressure, it's gonna be a different design. We'll go for hemispherical head instead of the flathead or any other ellipsoidal head. By orientation vessel gonna be different by different types of supports we are going to use. By head type, as I already told, by function also we are going to use the different types of pressure vessels. Like if you want to mix or if you want to have a reaction, we'll use the reactors. And by supports, as I already told, and we will see this one by one in detail. Based on shapes it is cylindrical, spherical, rectangular. Actually cylindrical is the most common pressure vessel you can able to see in almost all the industries. Spherical we are used only for high pressure application, very high pressure application. Actually it is very good pressure containing shape comparing to the cylindrical or rectangle, but the forming is very critical comparing to all other pressure vessels. A cylindrical is easy to form, rectangle is very easy to form, but the spherical it is very difficult, and some specified vendors only do this spherical pressure vessel. And for rectangle pressure vessels, we mostly, it is not a common one, we don't use this rectangle pressure vessel everywhere, but recently I have done a rectangle pressure vessel for SKF. It handles very poor stresses. We have to give more supports, and we have to provide extra thickness for particular places. Mostly in the corners it will fail very easily, so it is not a common pressure vessel in our field. Based on the orientation we have vertical pressure vessel and we have horizontal pressure vessel. For the vertical pressure vessel, it is common for towers, it is common for reactors, and it is common for air receivers also. We will go for the vertical pressure vessel. We will need very small area for a vertical pressure vessel. For the horizontal pressure vessel we need a large area. Mostly the drums and heat exchangers, almost 80% of the heat exchangers will be in horizontal, because it requires more surface area to do that process. To give more surface area, the vessel has to be horizontal. Comparing to vertical, the horizontal will provide more surface area for the tubes and other parts. Based on the function. Based on the function, we can able to separate by storage, by separator, by reactor, by heat exchanger, by steam drum, by flash drum, by air receiver, by accumulator. What is storage? It just wants to hold the pressure and reserve the pressure. That's it. There is no other purpose. Just want to hold the pressure and reserve the pressure. And for the separations, we need to divide it from the gas, from the oil, and from liquid or any bitumen. This is for separator. And for the reactor, reactor has two different kinds of reaction has to be happened inside a particular pressure vessel. And the heat exchanger, it needs to transfer the thermal energy from one fluid to another fluid, that is heat exchanger. And steam drums are mostly used to separate the steam from the water. It is mostly used in the boilers. Flash drum is mostly used to vaporize the liquid via pressure drop. Air receivers stores the compressed air in the plant, which is mostly commonly used in almost all the plants to supply the air to the equipments, which is like valves or actuators, those kind of pneumatic things. Finally, the accumulator collects the liquid before the pump. And based on the pressure level, actually it is one of the important place comparing to the previous thing. Why it is most important means, here you can able to see the code is differs. For the atmospheric tank, it is APA 650, and low pressure it is APA 620. For the pressure vessels, we are commonly used as ASME section 8 division 1, and for the high pressure we are going to use ASME section 8 division 2 and 3. Who is going to decide this? Which code we are going to use for the particular pressure vessels? We have more limitations for each and every code. If you choose APA 650, you can't able to design APA 650 vessel which has leg, which has saddle. We can't able to design using APA 650 or APA 620, because APA 650 or APA 620 requires a flat bottom which is supported on the ground or any concrete surface which has to be supported in the bottom. But our pressure vessel is different. So we can able to use this pressure vessel design, that means ASME section 8 division 1 for design these vessels also, for the low pressure vessels also. But we have some limitations, as I previously told, like APA we have some design restrictions in ASME also. And here I have mentioned from 15 psi to 3000 psi we can able to use the ASME section 8 division 1, and above that I have mentioned ASME section 8 division 2 and 3. It doesn't mean we can't able to use the ASME section 8 division 1, but under some limitations we can able to use. If the customer allows and if the AA allows, we can able to use ASME section 8 division 1. But what's the thing is, if you are using the ASME section 8 division 1 for the very high pressure vessel, thickness of the vessel gonna be very huge and the weight of the vessel will be increased. If the weight is increased, the manufacturing cost will be increased. If you want to reduce the material cost and the material weight, in that place the ASME section 8 division 2 comes into the picture. We can able to use the ASME section 8 division 2 for very high pressure vessels. And based on the head shapes, we are going to differ the pressure vessels. There are different types of heads like hemispherical, ellipsoidal, toruspherical, and flat ends. Actually, hemispherical is the real highest strength comparing to all these types of heads, but it is literally expensive comparing to all the heads. That's why we are not commonly use this hemispherical heads. Commonly used in high pressure vessels, it is not common for normal pressure vessels. But this 2:1 ellipsoidal head we can able to see everywhere. Almost in most industries we can able to see the 2:1 ellipsoidal head. That is due to it has a good strength comparing to the toruspherical and flat end. We have very good strength. The forming cost is really cheap. That's why it is used in almost all the industries. The next one is toruspherical. This toruspherical also you can able to see in most of the industries. It will be used in utility plants, it will be used in process plants. It is not used in high pressure equipments. It will be used in moderate pressure equipment. The strength will be not good comparing to the ellipsoidal, but it is a moderate we can able to use for the low pressure vessels. And comparing to the cost with all three heads, the toruspherical is cheap to manufacture. Finally, the flathead. The strength is literally very poor comparing to all these heads, because it is just flat, right? We can't able to view high pressure on a flat surface. If it is very thin wall, it will be bent, it will be prone to failure. Flathead are mostly commonly used in small pressure vessels, which is normally used in overhead tanks, those kind of things. We can able to use these flatheads. And here I have mentioned the cost is very high. That is not due to the manufacturing cost, it is due to the thickness. Even if you are giving a small pressure, we have to design the thickness which is 4 to 5 times higher than the shell. And the another separation is based on the support type: skirt type support, saddle type support, leg type support, and lug type support. The skirt type supports are most commonly used for the tall columns. If the vessel height is too large, in that place we will use the skirt type, and mostly the horizontal vessels have saddle support. Leg type supports are commonly used for small vessels. Most of the spears are supported with the leg type supports, and these leg type supports are mostly used where the vessel is located in the open spaces. The lug support. These lug supports are a brackets. Here you can able to see a small bracket. Mostly the vessel will be on hanging position. These lug type supports are mostly common for in-house pressure vessels. If the pressure vessel is available in the indoor, it is mostly lug type, because inside a closed area we have platforms and supports for this support lug. To hang a vessel, we can able to support using the platforms. So based on the supports also we are going to separate the pressure vessels. And also pressure vessel will be different for each and every industries. The most common types of air receiver, steam drums, LPG bullets, derators, KO drum, separator, reactor, surge vessel. Finally, how to choose the right pressure vessel? We can choose the pressure vessel based on process requirements, pressure, temperature, fluid type, capacity, material, vessel type, and ASME design. How can we able to choose different pressure vessel for the process requirement? As I already told, if the process requirement demands a vessel has to be vertical, we have to choose a vertical pressure vessel. For the pressure, if it is very high pressure, very high pressure, we can go with hemispherical heads. Temperature, if the vessel requires more temperature, we have to choose the material accordingly, because there will be creep, there will be fatigue. So we have to choose the material accordingly for the pressure vessel. Fluid types, if the fluid is very hard to clean and very hard to maintain, we can go with the horizontal pressure vessel, or we can able to clean the pressure vessel, we can able to maintain the pressure vessel easily. And based on the capacity, if the pressure vessel requires a huge capacity, we can go with the horizontal pressure vessel comparing to the vertical one. And material, we can able to choose according to the pressure vessel. If it is very corrosive area, we can able to choose a stainless steel materials. It is based on the area, is based on the liquid we are going to use. This is how we are going to choose the vessel type. Finally, based on ASME design. If a vessel is a storage tank, we can't able to use a ASME design. We can able to use API 650 or API 620. If a vessel is accommodate for ASME design, we can go with this ASME section 8, division 1, division 2, or division 3. And I have told there are different types of pressure vessel. Is the different types of pressure vessel only available in the different area? No. If you go to a particular plant, you can able to see all the different types of pressure vessel in a one particular plant, because there will be some steam drums, there will be some derator, there will be some separators, there will be some reactors, there will be some air receivers, there will be some heat exchangers. So this each and every process needs different types of pressure vessels. Getting the knowledge of different types of pressure vessel is very important. And finally, we have came to the end of the video. The final takeaway is, what are the multiple classification of pressure vessel? It can be by shape, it can be by orientation, it can be by function, and it can be by head type. And we have different types of pressure vessel based on industry wide, like power, we have different type of pressure vessels, oil and gas, and chemical. And custom selection, we can also select the pressure vessel based on the pressure, temperature, and fluid data that is depend on us. We can able to suggest the pressure vessel shape, or we can able to suggest the different types of pressure vessel to our organization, to our client. And finally, code compliance. If we are designing a pressure vessel using API 650, we can't able to design a pressure vessel using API 650 or 620. But anyway, we can able to design a storage tank. And based on the code compliances also, we are choosing different types of pressure vessels. Okay, finally, we are going to close the video. Keep learning. Bye-bye.